If you've ever seen the law of cosines before, it might seem a bit alien. You've probably seen a few common patterns within it and feel as if you kind of understand it, but it's still a bit foggy. However, the law of cosines is actually quite simple once you see how it is derived. So we're going to be proving that c squared equals to a squared plus b squared minus 2ab cosine c in any triangle. So let's construct our triangle, and we're going to draw a green line that is perpendicular to the red and blue side. And we're going to call this triangle ABC. And we're going to call the green line H, the red line B1, and the blue line B2. So note that sine of C, which is opposite over hypotenuse, so that would be H over A. So sine C is going to be H over A. We can rewrite this equation to get that H equals to A sine C. And we did this by multiplying both sides by little a. And we also know that cosine of C is going to be B2 over A. And we can also derive the equation that B2 equals to A cosine C. Again, we just multiplied both sides by little a. Now, by the Pythagorean theorem, we know that A squared plus B squared equals to C squared. So we're actually going to switch triangles. We're going to look at ABD, which is this triangle over here. So we know that B1 squared plus H squared equals to C squared. And we also know that side B is going to be equal to B1 plus B2. And we can also just rearrange this to get that B1 is going to be B minus B2. Now this makes sense because this entire side length is B, this side length is B2, so if you have B minus B2, then you would just get this remaining side length, B1. Now we can write our equation from this previous equation. We know that c squared is actually going to be equal to h squared plus b parentheses b minus b2 parentheses squared. And we can just plug in our values for h that we got over here into here, and the value of b2 that we got into b2 over here. Now once we plug them in, we will get that c squared equals to a squared sine squared c plus b minus a cosine c, and then you square all of that. Now there's a sine squared c because I just multiplied everything out. You just plug it into h, and you will see a sine of c squared is just going to be equal to a squared sine squared c. So that's how we got this part. Alright, so now let's basically expand everything. So c squared is going to be equal to a squared sine squared c plus b squared minus 2ab cosine c plus a squared cosine squared c. Now we just pretty much just expanded this equation out. And if you remember, a minus b squared equals to a squared minus 2ab plus b squared. So that's a simple way to get what we got here. So if you will notice, we actually have a sine c squared here, multiplied, which is a multiple of a squared, as well as a squared times cosine squared c over here. So we can put these terms next to each other and factor out the a squared, and we're going to get that a squared parentheses sine squared c plus cosine squared c plus b squared minus 2ab cosine c is all going to be equal to c squared. Now, if you will go back to the Pythagorean identities, we know that sine squared c plus cosine squared c is just going to be equal to 1. So we can write all of this, everything in the parentheses right over here, as 1. So, and 1 multiplied by a squared is just going to be a squared. So now we know that c squared is going to be equal to a squared plus b squared minus 2ab cosine c. Now that is pretty much everything that you need to prove the law of cosines. If this video has given you value or you appreciate this no BS concise way of teaching, then please consider supporting the channel. Thank you for your attention and good luck with your studies.